Okay, so good morning, everybody. So that's the last day of teaching for this certificate. It's my pleasure to introduce you, Kenny, who is part of a solution, a DLT on top of Bitcoin, where you can write smart contracts. In the afternoon, we will have a professor from University of Connecticut who is doing more also the specific programming language. As I told you, most of the time, I mean, when there is a new system, the people, they like to create their own programming language. So it's called Clarity, but this time for good reason. You will see, because it's there are some guarantees that to avoid security holes, that like it's more safer than Solidity. So that's for once it's a good actually it was needed, because Solidity, as you saw, is quite difficult sometimes to be sure there is no hole, bug, or security hole remaining. So Kenny, you can you have the co-host, all right? So you can start. You can ask to do a round. I mean, Stefan is not here yet, but it's recorded, so I mean it will be. They will be able to see it. And then Nora is also quite sick, as I said, so maybe she's not joining this session. So
Okay.
you have
Great. Yeah, I'll introduce myself real quick, and then we'll go through and I'll have you guys all introduce yourselves. But my name's Kenny. I'm the developer advocate at the Stacks Foundation. So I focus on developer education on the Stacks protocol, which is a Bitcoin L2 for smart contracts. And so yeah, today we're going to kind of go through what that looks like. We're going to look at a little bit of Bitcoin, a little bit of Stacks. I'll go through a little bit of Clarity. And then the person that's teaching with me in the second half of the day, Dr. Phil Bradford from University of Connecticut, he's going to be going through and kind of digging into some of the practical workshops for Clarity. So I'll kind of be going through Stacks as a protocol, Bitcoin development in general, why we need L2s, and then I'll kind of go through a bit of an intro sort of crash course to Clarity, and the second half will be some of the practical exercises. So yeah, that's me. And then yeah, if we want to go through a round of intros for everybody else, that'd be awesome.
Gilles, tu veux commencer ou?
Tu peux y aller, vas-y.
All right, so nice to meet you, Kenny, first of all. I discovered Bitcoin quite late, actually, in 2021 when I was working in a VC in Zurich. So I discovered quickly the flaws and how I didn't enjoy at all working in a traditional investment fund, which is kind of where my dad sent me. And I was like, what the hell? How does money circulate like this? It's a shit show. And then I discovered Bitcoin and the whole like benefits of it, and the true technical aspect and the fundamentals, not just speculating on an asset which is scarce, which is also interesting for people who just invest in it as a means of saving. But yeah, it's really going into projects and understanding the flaws that a blockchain or crypto project can have. And yeah, that's basically why I joined the CAS, and I also do other formations in parallel. Like I tried to learn a bit of Move, which is this language of this new blockchain that's been launched by a foundation that's interesting. But let's just say I want to understand the technical aspect of it, and not always just this pitch deck and business plan and people just talking out of their mouth for no reason. Like the truth is in the code in the end.
Yep.
That's
cool.
that.
Awesome. Thank you.
I'll go. My name is Gilles Bercier. I'm actually I work for a bank, and I'm on the tech side. I'm not a banker, and I manage the support team for the second and third levels of tech support. I'm passionate about technology. I mean, I've had the good fortune being in it since I was 17 years old, and I'm 57, so I've been in it for 40 years. But I've never, I'm not an official engineer. I'm a self-taught kind of guy. And my introduction to the blockchain world happened last year, when in 2022, when I became certified in blockchain through a program called Alira. It's a French program, which I think, I thought was quite an excellent program. And ever since, I wanted to learn more about it. I code a little bit, but I call myself as a Sunday coder. Like I said, I'm not an official developer, but I love bidouiller, as we say in French. I don't know if you understand that, Kenny. It means to mess around, with code. And I like front end stuff because I like things to look nice, and I try to do the back end as well and everything. And so that's kind of my background. And here I'm learning as much as I can, and looking forward to your presentation.
Awesome. Cool. That sounds great. Thank you. All right, Alex, you're up, and then I'll dig into things.
Hello, my name is Alexander, and I work in the police, and I am doing this training out of passion and desire to learn, simply.
Cool.
Thank you.
Awesome. Okay, I'm gonna share my screen real quick. We can start diving into things. Okay, cool. Everybody see the intro to Bitcoin and Stacks slide? Make sure I'm showing the right thing. Okay, awesome. Cool. I gave a little bit of an intro already, but again, my name's Kenny. I'm the developer advocate at the Stacks Foundation. So the Stacks Foundation, really what we do is focus on education and community outreach. And so our goal is kind of twofold. One, it's to grow the Stacks chain, but also to make sure that people that are using the Stacks chain, developers and users alike, are having the best experience that they can. So we do a lot of educational initiatives, community outreach events, hackathons. I do a lot of workshops and courses and that kind of stuff. So I'm focused on sort of the developer education side. And so that's where I come from. So today we'll be digging into some of the technical stuff for Bitcoin. We're not going to go super into the weeds. We'll do a little bit of Clarity demo. Phil's really going to be doing a lot of the hands-on workshops with Clarity later. But I'm also going to be providing a lot of resources if you do want to dig in deeper, because there's only so much we can do in one session like this. But another thing that I do want to say is, just with this amount of learning all happening at once, it's going to be a lot like drinking from a fire hose. And I don't want you guys to have to feel like you have to keep track and remember everything that's happening. So if you go to this link, stx.is/Geneva, this is just going to be a basic form where you can put in your name, email, GitHub and stuff. And then what I'm going to do is, after the class is done, I'll email all of you just with a list of further resources to explore, next steps, if you want to get more involved and keep looking into what Stacks and building on Bitcoin's all about. But that way today we can kind of focus on, we'll just dig into stuff. You guys can sit back, learn, ask questions, have conversations, all that kind of stuff. And then afterwards, if you're interested in digging in more, then I'll have resources for you to do that. So a little bit of a preview of what we're going to be doing today. First thing we're going to be doing is just an intro to Bitcoin. So one thing that I did want to know, just to kind of get a gauge on where everybody is at, does anybody here have Bitcoin development experience?
I don't.
Okay, cool. And if not, that's good, because
Negative, unfortunately.
Awesome. No, that's good. For today, that's good. That's where I was thinking everybody was at. And so today we're going to kind of be going over the fundamentals and the basics, and then I'll provide resources for everybody to dig in further. But I kind of wanted to make sure I wasn't going to be boring anybody with stuff that you had already been introduced to. So that's a good thing. Okay, I already asked that question. And then sort of a follow-up question. Has anybody looked into, even if you haven't developed or coded on it, has anyone really looked into how Bitcoin works at a technical level? So transactions, scripting, Bitcoin layers, that kind of stuff.
I have personally.
Okay, cool. What kind of, just in general, how it works, that kind of thing, how transactions are constructed, that kind of stuff?
Exactly. Understanding the Merkle tree. The technical detail of how these things actually really work, and also looking at different tokens, and an ERC20. And programming an ERC20 kind of token to see really how all the I mean, the necessary steps in how it works. Yeah, but trying to understand, yeah, at a very
awesome.
debutant level, you know.
Cool. Good. Awesome. Then should be able to have some good conversations. Some of this might be recap for you, but hopefully some of it not. Since I'm from the stack side of things, that's the specific L2 that I work with. I'm less informed on the BRC-20 ordinal side of things. We'll touch on it a little bit, and I will again provide resources for if you want to dig into that. But yeah, so just good context to have for everybody. So, okay, so first part of what we're going to be doing today, intro to Bitcoin, we're going to be covering a few different things. First of all, why build on Bitcoin? I think this is important to cover because there's a lot of other chains that exist that seem to be purpose-built for building on. Ethereum, Solana, the big two that come to mind right off the bat. Bitcoin has kind of been seen in the past as a little bit of a dinosaur. It was the original blockchain, but it's really, we even touched on this a little bit in the intros, it's a huge pain to build on. It's not enjoyable to build on. It's difficult. It's not really made to be built on. And so we're going to talk about, well, why should we even bother when these other chains like Ethereum, Solana exist? And then we're going to kind of go through the basics of how it works. So we're going to look at transactions, scripting, and then Bitcoin layers. And we're going to kind of go through those things step by step. And then while we do that, we're really going to start to see some of the limitations of building on Bitcoin and why we do need that additional functionality in order to actually build some decentralized applications using it. And then just for a little bit of context for everybody here, my primary interest personally is what I'm really interested in is, again, we touched on this in the intros, but the financial system is a mess. I think everybody that's involved in blockchain, crypto, Bitcoin, Ethereum, whatever knows that. And so the reason that I got involved in Bitcoin and stacks in the first place is because what I would really like to see is a decentralized financial system built on top of Bitcoin and a decentralized economy built on top of Bitcoin. And so when I talk about these things and when I approach teaching, when I approach development, that's really the angle that I'm coming at it is how can we take this decentralized money and then how can we create an economy that's just as decentralized, but using that money as the primary asset? So that's sort of just like the big picture context of how I'm approaching all this stuff. So then after we go through this introduction to Bitcoin, then we'll take a look at stacks, which is a Bitcoin L2 for smart contracts. We're going to look at what it is, what proof of transfer is, which is the consensus mechanism that stacks uses. We're going to look at stacks as a Bitcoin L2 and how it actually accomplishes that and what we mean when we say Bitcoin L2, because it differs a little bit from an L2 in an ecosystem like Ethereum. And then we're going to take a look at SBTC, which is an upcoming protocol upgrade to stacks, along with what we're calling the Nakamoto release, which is another protocol upgrade. And you're all getting a little bit of, like, to use a buzzword, you're getting a little bit of alpha here because this is all stuff that's in progress right now. But it's extremely important for stacks to actually function as a real L2. And so SBTC, we'll get into this more later, but what it is a decentralized two-way peg between the Bitcoin L1 and then SBTC, which is a synthetic Bitcoin peg on the stack side. Again, we'll get into all that later, but that's just a little preview of what we're talking about. And then along with that is a huge release to the stacks protocol, the biggest one ever, as far as I know, called the Nakamoto release. And those kind of coincide, as we'll see. Some of the changes we're making in the Nakamoto release are going to make stacks into more of a true Bitcoin L2. And some of those changes are also necessary for SBTC to function and actually be decentralized. So we're going to cover all that. And then the final section is we're going to go over Clarity, which is a smart contract language that Stacks uses. And it's really purpose-built to help developers more easily write safer, more secure smart contracts. So what we're going to do is I'm going to go over an intro to Clarity. I'm going to talk about it a little bit more from a conceptual level, and then I'll kind of do a whirlwind crash course through a Clarity smart contract. If you have some programming experience, you'll probably be able to keep up for the most part, but don't worry about understanding everything that we're doing. What my goal here is really to just let's talk about why Clarity, what makes it different, and then just get you introduced to a real contract and just get a high level familiarity of it. And then Phil's going to come in for the second half, and he's really going to walk through Clarity from the ground up and looking at the basics and doing some workshops and stuff like that. So what I want to start with is, I think everybody, yeah, go ahead.
I just had a question, and I know you're going to be talking about all of this, but I mean, when I hear about something being built on top of Bitcoin, I'm like, why would you do it? I mean, how will you scale? Because that's such a main issue. And then the second one is consensus, proof of work. I mean, why would you, is it still proof of work? What the consensus layer?
Mm-hmm.
It is?
Yeah. Sorry. So here, let me Bitcoin. Yeah. So Stacks uses what's called proof of transfer. And so we will get into all this, but I'll give you like the short version of the answers now, and then we'll kind of lay it all out. But why build on Bitcoin in the first place is exactly because of what you said, because of that scalability issue. So when I say building on top of Bitcoin, what I'm saying is keep Bitcoin the same. So Bitcoin right now is slow, it's difficult to use. We're seeing huge fee spikes right now. It's just becoming increasingly obvious that Bitcoin is not going to be super usable at the L1. And so why bother? And this is where L2s come in. Is I really do think that these things that are perceived as a weakness of Bitcoin, things like how slow it is, are actually a strength, because with that slowness and simplicity also comes security. And so if we can keep the core ethos of Stacks as an L2 is let's keep the foundational L1 as the money and as a settlement layer, and then let's build L2s on top of it. And in those L2s is where we'll add the scalability, the functionality, the innovation, the experimentation, all that stuff. So that's sort of the short version. And then for the second part of the question, the consensus mechanism, again, Stacks is not seeking to change Bitcoin at all. So Bitcoin will stay proof of work, but Stacks as an L2 uses a unique consensus mechanism called proof of transfer. And we'll go over how all of this works and how Stacks is actually connected to Bitcoin without needing to modify how Bitcoin works. We'll also touch on a little bit some other experiments that are happening in the Bitcoin L2 space that, in order to really work correctly, do require some changes at the Bitcoin protocol level. So we'll get into all of that in this first section, but that's like sort of the short version of the answer to your question, the teaser, I guess.
Great. Thank you so much.
Yeah. So there's a big sort of renaissance happening in this building on Bitcoin space right now. And I think it really happened when ordinals kicked off. Is Bitcoin's kind of always been seen as it's the original chain, but it's just money. It's slow. It's old. Yes, it kicked off the whole movement, but we've got better chains to build on. Ethereum is traditionally seen as the go-to chain for building. Solana is really starting to take off. But as part of this sort of renaissance in Bitcoin building, we're also seeing a new wave of innovation on L2s. So we've got, there are multiple L2s out there that are being worked on right now. RSK is one, Liquid, there's an experiment called Drive Chains, Spider Chains, BitVM, Stacks. These are all different variations on people attempting to use Bitcoin as the underlying asset and build more functionality or scalability on top of it. Lightning is another super common layer 2. Lightning doesn't necessarily change functionality, but it does change scalability. We'll talk about that a little bit. But let's get into a couple specific reasons for why people should bother building on Bitcoin in the first place, and specifically a couple of the reasons why I was drawn to it. And the first is that there's a huge blue ocean opportunity for developers. So if we look at the market caps of Ethereum and Bitcoin, this is what they are as of yesterday. I pulled the numbers off of CoinGecko. The Ethereum market cap is 272 billion. The market cap of Bitcoin is 852 billion. And even though we have this huge discrepancy, the app ecosystem for Bitcoin is nearly non-existent. And that's because it's really hard to build on and it's got a limited scripting language. Ethereum was built as a response to this lack of functionality in Bitcoin. Vitalik was originally a Bitcoiner, came in, he pitched what was basically the idea for Ethereum to the Bitcoiners. They were interested, but ultimately were like, no, too much complexity. And it didn't end up happening. So he went off and started Ethereum on his own. Well, he's clearly proven that there's a use case for that additional functionality. And so one of the goals with Stacks is, okay, how can we sort of bridge the gap here and have the best of both worlds where we're keeping the simplicity and the security of Bitcoin, but we're also able to add functionality on top of it. And then on top of this, Ordinals has really brought this new surge of innovation, interest in building. And we're kind of beginning to see the limitations of that with L1 fees spiking. Ordinals are really cool. It's really interesting that you can do that with Bitcoin. But we're starting to see that doing those things on Bitcoin is not practical. And Ethereum ran into this issue too. The more usage you have, the higher your fees are going to get. It's kind of a core, it's a feature of how blockchains work, really, is that fee market emerging. But it also introduces a new problem where, okay, how do we keep the security of this thing and keep this as a settlement layer, but make it scalable, make it easier and more accessible for users, cheaper to use, all that kind of stuff. So we have this blue ocean opportunity, but at the same time, it's really ripe for innovation because it's so young. But the funny thing about Bitcoin is it's the oldest blockchain, and yet the layers ecosystem for it is the youngest, and it's the most ripe for innovation. And so there's this huge surge of innovation happening right now. We're kind of starting to get to the beginning of another bull market. Ordinals are on the rise. Investments are starting to flow back into Bitcoin, and this is kind of resulting in this inflection point where we have a lot of experimentation on these L2s at the same time that the market seems like it's ready for that experimentation on these Bitcoin L2s, which I think is really exciting. Reason number 2 is we're building on a solid foundation. So we're all here to build what will hopefully be the future financial system of the world, and it needs to be built on a solid foundation. And I talked a little bit about this before, but I do think that Bitcoin's limitations are its strengths. So all of the criticisms of Bitcoin assume that it will be primarily used at the L1, and I don't think that's necessarily the case. I think that's the wrong way to look at it. If we're being honest, Bitcoin is slow and it has limited functionality, but I think that's actually a good thing. Like, we want Bitcoin to remain simple, secure, stable. What we really want is we want Bitcoin to function as a settlement layer. But then we need L2s, and we'll talk about these a little bit more later, but we need L2s to serve as sort of the experimentation ground and the innovation and the rails that will facilitate the scalability and functionality that we need. And the reason that we want that at the L2 and not the L1 is that increased functionality always comes with increased complexity. So the more functionality we have, the more complexity we have. Yeah, go ahead.
Yeah, can you give me a little a recap of ordinals and its use? Because my understanding of ordinals, it's like it allows you to inscribe digital artifacts directly onto individual satoshis.
Mm-hmm.
But what is it now that you can do that? What is it used for? I mean, why? What are the true usefulness of ordinals?
Yeah, so what they're mainly being used for right now are people that just want to have fun with it. You can compare their use to an NFT. The difference is that whereas an NFT mainly serves as like a record of ownership and it has a pointer to an asset, with ordinals, the asset themselves are stored directly on chain. And so right now, people are using it for a lot of the same use cases that they used NFTs for when NFTs went through their big boom. Was they're using it for art, they're using it for PFP projects, that kind of stuff. So the answer to what are they useful for is really any data that you want to live on the Bitcoin blockchain permanently. And the answers to that are endless. The problem that we're seeing is that because this is not really what the Bitcoin base layer was designed for, we're seeing that fee market skyrocket, which I think is good for the chain, because one of the big criticisms of Bitcoin in the past has been what happens when the Coinbase reward runs out. When the whole mentality of Bitcoin is buy and hold, you can't really rely on transaction fees to maintain the economic security of the network, because right now miners' primary incentive is the Coinbase rewards. Well, we're seeing that change a little bit now with ordinals. We're seeing those transaction fees rise. Well, but then you introduce the new problem of, okay, great, now we have high transaction fees, but now everyday people can't use it. If you want to send a small amount of Bitcoin, it's not worth it to do it at the L1. And so what we're seeing then because of that is people moving towards custodial solutions. Well, the alternative to that is, okay, well, how can we make decentralized L2s that will sort of treat Bitcoin as this settlement layer that everyday users will likely not interact with that much? But rather than having them need to shift to custodial solutions, can we create a decentralized version of an L2 that's cheaper, easier to use, much faster, that kind of thing? So I kind of veered off the original question of what are ordinals for, but yeah, the short answer is the use case is anything you want permanently stored on the Bitcoin blockchain, but I think what we'll see is that the block that's going to drive up the cost for the block space. And so we're going to start to see more things move to the L2, and we're going to start to see only high value transactions actually happen on the L1. I think is what's going to happen. That's the way I see it, at least.
Great, thank you.
Yeah. So the core, I guess, ethos behind all this is the goal is simplicity at the L1 and innovation at the L2. So we want to innovate at the L2 because we can innovate safely. We don't have to add complexity, and we don't have to add new attack vectors, which inevitably always come with more complexity. So we want to keep Bitcoin as secure as possible, as simple as possible at the L1, add all the innovation at the L2. So let's keep going. Let's dive into transactions a little bit on Bitcoin. So really the easiest way to think about transactions is they're just data. So when you make a transaction, all you're really doing is you're just sending this data to the network of Bitcoin nodes. Eventually, one of the nodes on the network is going to mine your transaction to a block, and this block with your transaction in it is going to be added to the file of confirmed transactions, which that whole thing is what comprises the blockchain. It's just a gigantic ledger of transactions. So all a Bitcoin transaction really is you're just feeding a simple line of data into the Bitcoin network and waiting for it to be mined into the blockchain. And so here we just have a super simple diagram of what a Bitcoin transaction can kind of be conceptualized as. It's just an amount, and then a from address, and then a to address. And obviously this is oversimplified, but this is basically the way that you can think about it. Your transaction is just a line of data, and you're just sending that to the Bitcoin network. If it's valid, they propagate it to the rest of the network. If it's not, it gets rejected. So let's dig into a little bit how this actually works. So again, for a lot of you, this might be recap. So if it is, I apologize, but we'll go through the basics. I'll provide some more resources to dive in deeper, because we are really just going to cover this from a surface level, because there's an amazing amount of cool cryptographic techniques that go into all of the stuff that comprises Bitcoin. Transactions are no exception to that, so we'll cover the basics here, but I'm going to provide some resources for people if you want to dig in further. So, okay, basics. A Bitcoin address is just like an account number that holds Bitcoins, but when you make a transaction, it's not like taking an exact amount of coins out of a pot and moving them into another. So other chains like Ethereum and actually Stacks use what's called an accounts model, where you're basically just taking an amount of tokens and you're moving it to a different address. That's not quite how Bitcoin works. What actually happens is an address keeps track of each individual transaction it's received. So when you want to send Bitcoins to someone else, what you're really doing is you're grabbing whole amounts that you've already received, and you're using them as inputs to send that new amount to an address. So then when someone you're sending them to wants to send Bitcoins to another person, they'll also use up those whole amounts they've received in the same way. So really what happens is you actually receive Bitcoins in batches, and then you use those batches to create new batches to send to other people. That's how transactions work. It's called inputs and outputs. And it's the core thing that makes up your balance as a Bitcoin holder is your UTXO set. So it's the collection of these unspent transaction outputs that you have had sent to you. And we'll dig into a little bit more about how all this works next. But that's like the super high level of how transactions actually work, is you kind of send them in batches. So let's say I, as a user, I had somebody send me, as this diagram on the left shows, I had somebody send me Bitcoin, 1 Bitcoin, and then I had somebody send me 2 Bitcoin, and then I had somebody send me 3 Bitcoin. So I've got 6 Bitcoin, but those are all split up into individual UTXOs consisting of 1, 2, and 3 Bitcoin. So if I want to send somebody 5, what I have to do is I have to take my 2 Bitcoin input and my 3 Bitcoin input, and I have to send both of them to this new person, and that will then create a new UTXO for them that says you have 5 Bitcoin that basically you are the only person that can actually use these. And so it's a little bit convoluted, but it's an efficient way for the network to process those transactions. But because you can only send them in whole increments, we have this concept of change in Bitcoin. So what if the total amount of batches adds up to more than I actually want to send? So then in this case, what we have is a change transaction. You can think of this just like if you're paying with cash at a store. If I'm buying something that costs $15, but I only have a $20 bill, I'm going to give the cashier my $20 bill, and they're going to give me $5 back in change. That's very similar to how inputs and outputs and transactions work in Bitcoin. If I'm trying to send you, like this diagram shows here, 4 Bitcoin, but I only have an UTXO with 2 Bitcoin and a UTXO with 3 Bitcoin, I have to send both of those as new inputs in this new transaction. And then what's going to happen is my wallet software, as part of that transaction, it's going to say, it's going to create 2 UTXOs. It's going to create one of 5 that goes to you, and then it's going to create another one of 1 that goes back to me. So you're going to end up with 4, and I'm going to end up with 1. So it's a little awkward at first, but from a programming perspective and from the perspective of how nodes in the network actually process it, it's a little bit more efficient, and that's just how it works. So you have a Bitcoin address. Bitcoins arrive at the address in batches called outputs, and the Bitcoin transaction is the process of using these outputs to create new outputs that belong to someone else's address. So when I receive Bitcoin, I receive somebody else's output. And then if I want to send that to somebody else, that then becomes an input to a new transaction. And then when they receive it, that's an output, or a UTXO, which is an unspent transaction output. So that brings up a question then. If making a transaction is just a case of feeding a line of data into the Bitcoin network, why can't someone construct a transaction that includes my address and use it to send Bitcoins to their address? And the answer to this is because each transaction output has a lock. And this is really where the cryptography part of Bitcoin comes in. You're all probably familiar with how this works, but we're going to dive into the foundations of what is a really critical component of not just Bitcoin itself, but also building on it as a developer, both of the base layer and on L2s, because ultimately these output locks, these comprise all of the functionality that we can have within Bitcoin. So if we want to build on Bitcoin, we need to understand and be familiar with how these output locks work. And then if we want to build on top of Bitcoin L2, it's important to understand what's happening behind the scenes with that connection between the L2 and the L1, because ultimately the way that an L2 is going to work is it's going to utilize these output locks, and it's going to manipulate them in different ways in order to move Bitcoin around behind the scenes, while you and me as the L2 developers, and then one level more removed as the user, we're going to be interacting with the more user-friendly sort of abstracted stuff for us as the developers with the L2 with a smart contract language like Clarity, and then for the user through user interface. So let's go into a little bit more detail about how these output locks actually work. Again, this might be recap, but we're going to go over the basics and fundamentals, and then we'll extrapolate it out a little bit to how it works for an L2. But every Bitcoin address has an associated private key, and these private keys are literally keys that will unlock these locking scripts that we have on each output. And you're the only one that can unlock them. So this is kind of the fundamental cryptography concept that underpins how blockchain technology works, which again, you're all probably familiar with, but it's important to cover how this works in Bitcoin because it's relevant to building on Bitcoin with L2s. So these transactions include locking and unlocking scripts. The outputs that you send to another person contain a locking script that can only be unlocked by the address you are sending to. We covered this before, but this is called a UTXO, which stands for unspent transaction output. So an unspent transaction output is really the core of everything that composes the Bitcoin ledger. Is composed of what's called the UTXO set. And this is the collection of all of the unspent transaction outputs that exist on the chain. And it's an output at your address with a locking script. And it's the foundational unit that makes up the Bitcoin ledger. So the UTXO, your UTXO set equals your Bitcoin balance. So if you're looking at your Bitcoin wallet and it says you have 10 Bitcoin, that doesn't really correlate to I have an account with 10 Bitcoin in it. What it correlates to is I have a UTXO set where the total amount of all those UTXOs adds up to 10 Bitcoin. And that could be in any combination of Bitcoin, but you have to use those as individual units. So how do you actually create an output lock? That's where Bitcoin script comes in. So output locks are built in a basic programming language called script. And script is the programming language underlying Bitcoin transactions. It's extremely simple, which is great for security, but it's weird to work with, and it doesn't have a lot of the complex functionality like a smart contract would. So we're going to look at a quick basic example of it. So right here, I don't know if this is blurry for you, but I'll walk through what it says just in case, because it's a little bit blurry on my end. But this is a basic version of a locking script using the checksig function right there, you can see in the middle. So this is a function that's built into script that will take a given digital signature and cryptographically check if it matches the address listed. So a digital signature is what we use so we don't have to give away our private key. And it's just in Bitcoin, it's just generated by generating unique hash based on a random number, your private key, and then ECDSA cryptography, which stands for elliptic curve digital signature algorithm. We're not going to go over that here because it's extremely complex and it's, just out of the scope for this class, but I am going to provide resources for if you do want to dig into it for yourself. If you're interested in building like smart contracts, pretty unlikely you're ever going to have to interact with this directly, but it's still interesting and helpful to know how it works. So when a node receives this transaction data, what it's going to do is it's going to run this unlocking script from left to right. And if it returns 1, then it's considered a valid transaction and it will propagate it to the network. If it returns anything else, it's considered invalid and it ignores it. So what this transaction is doing here is this is taking a Bitcoin address as the first argument, and then it's going to pass that in to the checksig function, and that is going to then take that signature that we have visualized there on the just to the left of the equal sign, and it's going to say, does this digital signature match up to this address? If it does, it considers it true, the transaction is considered valid, and it propagates it to the network. And this is really the core of how Bitcoin script works, is we have this super simple scripting language with these simple functions called opcodes, and those are going to interact with this data from left to right, and then it's just going to return true. If it returns true, the transaction is considered valid. So that's the core of kind of how script works, and it's a stack-based language. So what that means is that we can kind of envision literally a stack of values, and then these functions called opcodes, and what script will do is it'll pull each item out of the stack, it'll execute on it one at a time, and then it'll pop it back onto the stack, pull it out of the stack depending on what the function is, and ultimately, after it's processed every item in the stack, it'll evaluate to some value. If it evaluates to 1, transaction's valid, anything else, not valid. So let's take a quick look at how this works. This is one of my favorite websites to learn about Bitcoin. It's called learnmeabitcoin.com. If you're interested in how Bitcoin works from a technical angle, this website is extremely helpful because it covers the basics of how stuff works, but it also really gets into the weeds on like the cryptography that we talked about, exactly how all these different scripts and transactions are covered, and all that stuff. So I'm going to open this up real quick, and we're going to kind of run through the example that's on this site. Sharing real quick because I need to switch what screen I'm sharing. Cool. So the reason I want to bring this up is because this website in particular does a really good job of visualizing exactly how script works. And so you can go and visit this site if you want to on your own. Again, it's learnmeabitcoin.com, and we're on the script page right now. So if you go to technical, there's this script section right here. We're looking at that. And then we're just looking at this, what is the script language section? So like we covered a minute ago, script is just it's a very basic mini programming language, basically, and it contains data and these opcodes. The opcodes are the functions that are built in. And so what we have right here is this is a diagram of what's called a P2PKH, that stands for pay to public key hash script used in Bitcoin. And prior to the SegWit upgrade, which happened in, I think, 2017, 2018, this was by far the most common script that you would see in Bitcoin. And that's because this is just how you pay somebody else. Now it's also common to see a P2PWKH script, which is a pay to witness public key hash script. And that we're not going to go over SegWit today, but again, that would be something else that would be worth looking into. But what SegWit did is it stands for segregated witness. And what it did is it just changed the way that data is stored on the Bitcoin chain. And segregated witness means that there's a collection of data called the witness data that was literally segregated from the transaction. It was mainly designed to save space, but it means that you have to kind of process transactions differently. So you'll see both of these now. You'll see this P2PKH script, but then you also see the SegWit version, which is the P2W PKH script. So let's look at down here a little bit, because this is the visual that I think is super helpful, is how do you actually run a script? And so what happens is the complete script is run from left to right. And then while it's running, it makes use of this data structure that we talked about called the stack. So we have this data here, and then what happens is you can think of the data from left to right as being pushed on top of the stack. So the data gets pushed, and then every time we have one of these opcodes, that's going to manipulate this data in some way. So what this dupe function will do is it'll pop these elements off the stack, and then it'll do something with them. In this case, it's going to duplicate them. And then what it'll do is it'll sometimes push new elements onto the stack. So in this case, what we're doing is we're first pushing this data right here. In this case, this blue key here is the public key, or I think that maybe the private key in this particular example. And what we're doing is we're duplicating it. And then that duplicated item now becomes the top item on the stack. So then the next function down the line, this hash 160, this is going to then interact with that piece of data potentially, and that's going to return the hash of that. And then now we're going to push on the next piece of data. In this case, this little symbol corresponds to a digital signature. So then that will be on the stack. And then the equal verify is going to pop off next. It's going to take two items, see if they're equal. And then we go on down the line until we get to the end. And if it evaluates to 1, then it's considered a valid transaction. So the script, there's all kinds of conditions that can make the script invalid. The only one that we really care about for it being valid is if it returns 1. If it returns anything else, then it's considered invalid. And whatever node receives that transaction first, we'll just ignore it. It won't propagate it to the rest of the network. It won't get written to a block. And then the answer to where can you find script in Bitcoin is really everywhere. Every single output that gets created has an unlocking script and a locking script. And if you don't provide that, that by itself is considered an invalid transaction. And the reason we don't really interact with script much is because most of the time when we're just sending Bitcoin from one person to another, we're using some version of this P2 PKH script, or we might be using something that has to do with a multisig. But you can see from what we're looking at now, this is, if you're used to normal programming languages, like I am, I originally started with JavaScript and PHP. This is weird. It's awkward to work with. It doesn't have a lot of functionality. It's really ultimately just an extended chain of conditionals. If this equals this, then do this. But it doesn't have any, there's no real state management other than the UTXO set. So you can't add arbitrary data and save it. There's no concept of like data structures at all. And so you can't really do much with the script language other than maybe create some slightly more complex conditions for when Bitcoin can and can't be spent. But you can't create a like DeFi protocol using something like that. You can't really do anything but decide who to pay when they can use their Bitcoin. You can create things like hash time lock scripts, which is where you can say this Bitcoin isn't allowed to be spent until this time. But again, there's no complex logic and data handling happening here. So if Bitcoin is really just for, sending transactions between people, why don't we just use a simple public key and signature comparison and not bother with all this opcode stuff? And the answer is because we do want to be able to create different types of locks with different combinations of opcodes. So I'm going to do a very simple live example here, and then we'll take our first break, and we'll come back after this live example and keep going. But if you want to follow along, you can go to this URL. This is a URL shortener I have set up here, stx.is/bitcoin-IDE. This is just going to take you to an online Bitcoin IDE that I like to use. So I'm going to switch over to that real quick. You can follow along if you want. Otherwise, you can just watch me do it either way. But I'm going to open that up real quick. And we're just going to look at a super simple example just so we can kind of visualize how this actually works in practice. So this is a super simple Bitcoin IDE. Well, this is just the default example that shows up as soon as you go into it. And the thing that I like about this IDE is it allows you to go through step by step. So it'll tell you right here what the next argument is. And we can see it's got that stack visualizer, just like the Learn Me a Bitcoin website did. And we've got our data right here. So if we go to step on here, we can see that the next argument is going to be 1. Put that in here. It'll drop that onto the stack and show us right there. Hit step. It's going to tell us the next argument is going to be 2. Right now, all we're doing is we're just adding data to this stack. What we're going to do next is we're going to now add an opcode. And instead of just adding data to the stack, this is going to operate on it. You can probably tell what this is going to do. We hit step, adds them together, returns 3. So that's what that does. If we go back to Learn Me a Bitcoin, what we're going to do is we're going to generate a public key. So we've got this public key right here, and I'm going to go back to our IDE, and I'm going to start with that first piece of data. So right now we just have a public key, and right here is our first piece of data. And all I'm going to do right now is I'm just going to apply this hash 160 function to this. And what this is going to do is this is actually going to hash it twice. First, it's going to use SHA-256, and then it's going to hash that using RipMed 160. And so the shorthand for that is just hash 160, hashes it twice. So if we hit this step, again, it's going to tell us what's coming up next. We've just got our public key right there. Next argument is going to be this hash, and then it's going to return us the hash. So what I'm actually going to do is I'm going to copy this. I'm going to put it right here. I'm going to get rid of this. We're going to add in a new opcode here, equal verify. So now if we step through this again, we've got our public key right here. Next argument is the hash 160. Going to hash that. And then the next thing is we're putting in the actual hash, adding that to the data stack. And then we're going to check and see if they're equal. And it says execution successful. Now, obviously, this was a convoluted example because I just copied the hash. But this mimics a very simplified version of how a Bitcoin node would verify that somebody had a legitimate transaction. Is it's going to take your digital signature, and it's going to compare that using that check sig function with a public key. It's going to make sure they match, and only if it matches is it going to process that transaction. So that's the basics of Bitcoin transactions. And then we're going to go ahead and take our first break. I'm going to try to stick with the 15-minute break every hour. We've been here for just under an hour, so we'll take our first break slightly early. But yeah, if anybody has any questions right now, we can answer those right now. Otherwise, I'll see you guys in about 15 minutes. Hey, how's it going? Nope, you're muted.
On t'entend pas, Stéphane.
Là, c'est bon, je suppose.
Yeah.
Yes.
That's
Cool. All right. Everybody's back. So I'm going to do a quick recap of what we've covered so far. Also, my name's Kenny. I'm the developer advocate at the Stacks Foundation. So talking about Bitcoin, Stacks, which is an L2 for smart contracts. What we've covered so far is just the basics of kind of how Bitcoin works from a super high level, just transactions and scripting and that kind of stuff. I'm about to kind of recap what we've covered so far really briefly, and then I'm going to provide a list of resources. This first website that I'm going to list and the resources, you check out the beginner and the first parts of the technical sections on that website. You'll be totally caught up with everything we covered here. Anybody here that was part of the first part of this, you can go check that out, and it'll go as in depth as you want to on some of the stuff that we talked about. But let's start with just a recap of what we've covered so far. Share my screen again. So what we just finished covering is that script is a mini programming language inside Bitcoin that provides locking mechanisms for outputs. So every output's given a locking script. You then provide an unlocking script in the transaction attempting to spin that output. And then when a Bitcoin node on the network receives that spending transaction, it's going to combine these scripts and it's going to run them. If the result evaluates to 1, it's considered valid. The transaction's propagated to the network. And if it's not, it just gets rejected. And this 4-step process is essentially how the Bitcoin works and how all these transactions actually happen. So I'm going to leave this slide up for a minute so that you guys can write down whatever you want to write down. But this first one on here, learnmeabitcoin.com, this is one of my favorite resources for learning Bitcoin. One, because you can stay surface level and just get introduced to the basics. You can dig super deep into elliptic curve cryptography and how all that works. And the explanations and the visualizations are really simple and really helpful. The other 3 are all books. The first one is Mastering Bitcoin. Second one is Grokking Bitcoin, and the third one is Programming Bitcoin. Mastering Bitcoin is going to be sort of like an all-around technical how Bitcoin works from start to finish. Grokking Bitcoin's sort of along the same lines, but rather than it being from a programming perspective, it does teach you how Bitcoin works from a technical perspective, but it uses a lot of like real-world analogies, which can be helpful for a lot of people. I found them really helpful when I was learning about how it worked. And then Programming Bitcoin is going to actually teach you how to basically recreate how Bitcoin works in a lot of ways using Python. And so they kind of all approach it from different angles, all super useful. If I had to pick one to start with, I'd probably recommend learnmeabitcoin.com just because it's the most accessible. And then if you want to dig in deeper, you can kind of go and check out those books. So now that we have kind of covered how Bitcoin works from a technical perspective and what the basics are, I want to get into this concept of Bitcoin layers because, hold on, I think somebody's trying to come in real quick. Maybe not. I saw somebody trying to come in, but I don't see anybody. All right, I'll keep going. So, want to get into this concept of Bitcoin layers. A good chunk of what we just looked at, looking at how transactions and scripting works, the scripting language is 1, kind of clunky and cumbersome and weird to use, and 2, it's pretty limited. It doesn't do that much, doesn't unlock a lot of different functionality. And then as we talked about at the beginning, and as that everybody in this class is probably aware of, Bitcoin is not very scalable. It's very slow. Even right now, we're seeing network congestion that makes it extremely difficult and infeasible for people to just send small transactions. And so what we really need to start looking at is if we want to utilize Bitcoin as this sort of foundational settlement layer of a decentralized economy, we really need to start thinking in layers, because building on the Bitcoin L1, 1 is just not a feasible or practical option. And 2, I don't think it's a desirable option either. I think the separation and separating things out into layers is actually the better way to go. So we can think about this, and there's 2 types of layers. 1 focuses on scalability, 1 focuses on functionality, and layers can do both, or they can focus on one or the other. The most well-known example is probably Lightning. And Lightning is a layer focused entirely on scalability. So it doesn't actually add any new functionality to Bitcoin. You can still just send payments back and forth to each other. But what it does do is it helps you do this significantly faster in theory. And what Lightning is, it's a channel-based system. And so how it works is you take your Bitcoin and you lock it in what's called an HTLC, which stands for hashed time lock contract. And then what you do is off-chain, you create these channels with other Lightning nodes and other Lightning participants, and you can transact with those people and those Lightning nodes off-chain. And then what you'll do is the Lightning network will take all of those transactions, it'll batch them, and it'll write a settlement transaction back to Bitcoin with the final result of that. And then that channel's gone. And so this is sort of the main difference between Lightning and a lot of other L2s is Lightning's ephemeral. There's no concept of state in Lightning. So if I open a channel with somebody, once I close that channel and write that settlement transaction back to Bitcoin, there's no record of what happened on Lightning. That's gone. It's just the final transaction that I have the record of. And then the other challenge with Lightning is it uses its routing system. So basically, if I want to transact on the Lightning network, I have to hope that there's enough liquidity within the system so that my payment can be routed through the different nodes to a point where it has the liquidity and I can bounce that back and forth through the system. So if there is only, I think right now, last time I checked, there was around 5,000, I want to say, Bitcoin in the Lightning Network as liquidity. Well, I am relying on that liquidity to transact on the Lightning Network. And so what we've seen is that because you still have to you have to initiate a Bitcoin transaction in order to open and close a channel, we're actually seeing Lightning be affected by a lot of this high fee environment and by this network congestion. And so it was originally created as a scalability solution, but it's not quite working out that way because of this liquidity issue, because of the routing system. And there are solutions in the works to fix things. There's a company called Lightspark that's looking at using AI to kind of make this routing process more efficient so that liquidity issue is not as much of an issue. But you still have to initiate that Bitcoin transaction to open and close a channel, which people are having to do more often than they anticipated having to do. And so this whole idea of off-chain payments, it's not happening as efficiently and as well as people hoped. And so it's kind of running into some issues. We'll see what happens in the future with that. But either way, Lightning is not a layer that's designed to add new functionality. It's a layer that's designed to add scalability. So if we look at some other L2s, we can break them down a little bit further into different categories. And the first one's called federated. And I would put Liquid and RSK in this category. And what federated means is that this other chain, so Liquid or RSK, is technically a side chain that's running alongside Bitcoin. And the transactions in and out of the layer 2, so somebody taking Bitcoin from their L1, putting it into LBTC and Liquid or RBTC on RSK, and then doing whatever they're going to do with it with the smart contracts on the side chain, and then pulling it back to their L1 wallet on the Bitcoin chain. That process is going to be managed by what's called a federation, which is basically a closed set of entities that are responsible for collectively processing those transactions. And so this is a closed system. So this is not what I would describe as decentralized, although it can be very efficient and very fast. It's a closed network. And so one of the great things about Bitcoin is that anybody can join and run a node, anybody can join and run a miner with these federated systems. That's not quite how it works. And so as we'll see, as we kind of start to look at these different L2 solutions, there's different trust assumptions that need to be made and different trade-offs with each one. There's a few more that are really brand new, and these are really just in kind of like the theoretical stage right now. We're seeing ideas and white papers develop on how these might work, but there's not a lot of real world use case of them yet. And they all work a little bit differently. Drive chains, spider chains, BitVM. We're not going to go into the details of the design of all of these, but they're all experiments designed to expand the scalability or functionality or both of Bitcoin, and they all do it in slightly different ways. And so I'm really excited about all this innovation happening at the L2 level, because I think we're seeing the real world result of people realizing that now is a good time to build on Bitcoin, but also at the same time realizing we have to come up with other solutions if we're actually going to do this effectively and use Bitcoin as sort of this foundational money and foundational settlement layer. The more experiments we have, the better. The more people coming up with different systems and different ways to add this functionality and scalability to Bitcoin, the better. So I'm really excited to see all of this. And then I want to sort of explore an analogy that might help to illustrate how to think about this whole Bitcoin and the L2 thing. So if you're familiar with Fedwire, and if you're not, I'll explain how it works at a high level in a second, but you can think of Bitcoin as Fedwire and the L2s as the faster, cheaper rails. So Fedwire's it's a high-value real-time settlement system, and it's used by banks to transfer large sums of money. But it's not really something, even though it's used behind the scenes in all of our banking interactions, it's not something that everyday people interact with in our daily transactions. And the reason is because it's complex, it's cumbersome, it's not cost-effective for smaller, frequent transactions. We can't really do anything but basic bank-to-bank transfers, but it's secure and it's established. It's trusted, for whatever that means in the current financial system we have. So we can think of Bitcoin as a sort of decentralized equivalent of Fedwire. It's secure, decentralized network where every transaction that happens is recorded to that foundational settlement layer blockchain. Except with Bitcoin, obviously, the ledger is transparent and immutable. But like Fedwire, it does have limitations in speed and scalability. Each transaction requires a network consensus, which means it has to propagate through the entire network. And in order to keep Bitcoin as decentralized as possible, we need to make sure that it is as easy as possible to run a Bitcoin node. And so if you look at systems like Solana, they have to make this trade-off where in order to process these really fast transactions, they're making trade-offs with the hardware requirements that it takes to run like a validator. It's not as accessible to run a Solana validator as it is to run a Bitcoin node. So just by nature, it's not going to be as decentralized. Again, not necessarily better or worse, but we just have to think about these different trade-offs when we're looking at what we're going to build on. So this sort of like super secure, super decentralized, but then that also comes with simplicity, lack of functionality, and slowness. This is where layer two solutions can come into play. So they're basically to Bitcoin what you can think of like everyday banking services are to Fedwire. They allow for faster, more frequent transactions because they process them separately from the main underlying settlement layer in an abstraction layer that is easier for us to interact with. And then behind the scenes, they're then settling that back down to that layer. And then once they're settled down back to that layer, that's when they're considered really permanent and irreversible. So you can kind of think of the L2s that we're trying to build for Bitcoin as like a banking app or a fintech app that we might use today. We are not interacting with Fedwire. We're interacting with this easy to use, fast app. And from our perspective, it's happening right away. And then it'll settle back down to Fedwire. But obviously, the difference that we are trying to achieve is how can we do that in a transparent, permissionless, decentralized way? Because obviously, these other solutions are not that, which is the entire point of why we're here in the first place building this stuff. But conceptually, this is kind of how you can think about it and where the need comes from. So this is kind of how I envision Bitcoin working as this global, immutable, extremely secure, decentralized settlement layer. And then L2s are the banking apps, the fintech apps, the easy to use rails that kind of abstract the slowness, the simplicity and the complexity and the cumbersome nature of the settlement network away from the everyday user. So as developers, kind of our job to build these robust L2s on top of this system so that we can allow people to easily and cheaply utilize its security. And our goal should be to do that in as trust minimized a way as possible. So the challenge we run into then is that in order to do that effectively, in order to run an effective open network, we need incentives. So I want to go into a concept called the Bitcoin L2 trilemma. We've got the blockchain trilemma. We've also got the Bitcoin L2 trilemma. So let's walk through what this kind of looks like real quick. On the right-hand side here, we've got no new token. So you can think of these sides of the triangle with the black text as the benefits, as the good things, and you can think of the corners with the orange text as each of the different types of L2s or sidechains that we're going to create. So you have to pick two because you can't have all three of them. So you can either have an open network and no new token, and that's where you have something like Lightning, where it's an off-chain network. But what you don't have there is you don't have a full VM on a global state because there's no incentive for miners and nodes to maintain that perpetual ledger that we see when we have a blockchain. You go to the federated sidechain. With this, you don't have a new token, but you do have that full VM and global state. But because you don't have that new token, there's no incentive for participants to come in and participate in this open network and mine it like they do. If you look at Bitcoin, Bitcoin is a token, and its existence and the Coinbase reward and the transaction fees, that is the incentive for miners to come in and mine the Bitcoin chain. Well, if you don't have that incentive, there's no reason for people to come in and maintain that network. So then that brings us to a decentralized sidechain. And in this case, it's an open network, and we have the full virtual machine and the global state, but we do have to introduce a new token so that we can have those incentives for people to come in, join the open permissionless network, mine it, and be incentivized for maintaining the chain state and running the network with that token. And this is really where Stacks comes in. So Stacks fits into that last category. You can call it a decentralized sidechain. You can call it an L2. This is all very new to the Bitcoin world. This sidechains, L2s. So the terminology is still sort of in flux. What we're going to do is I'm going to go over 7 properties that I think make an ideal Bitcoin L2. And we'll kind of look at where Stacks fits into those. But Stacks is, at its core, a Bitcoin L2 that's designed to bring smart contract functionality. So let's dig into a little bit what we actually mean when we say a Bitcoin L2. There's a lot of nuanced opinions on this. The ecosystem's still young, so things are still kind of being fleshed out. But I want to go through 7 properties that we can look at that I think are a good starting point for establishing what an ideal Bitcoin L2 will look like. And as you'll see, because this ecosystem is still so young and because Bitcoin is so slow to evolve, we actually can't hit all 7 of these yet. Now, work is in progress to enable some of them. And the goal of Stacks is really to, how can we create the most practical, most usable version of an ideal Bitcoin L2 right now with the way Bitcoin is, without having to introduce new changes to Bitcoin. So some of those other experiments and innovations I looked at before, specifically drive chains, and then rollups are another concept that people are looking at adding to Bitcoin. Those are great, and I hope that those get integrated, and if they do, Stacks will very likely utilize them in the future. The problem is that in order for those to work correctly, we have to add new opcodes to Bitcoin, and that's very likely going to take years. And so the approach that Stacks takes is, how can we hit as many of these properties of an ideal Bitcoin L2 as we can with the way that Bitcoin is right now, and then iteratively improve on these as technology gets changed and new technologies get invented, discovered, released, all that kind of stuff. So let's go through these 7 properties. The first one is, it has to have an open source and decentralized development process. This one's pretty self-explanatory. If the technology that's being built is being built closed sourced by a centralized company, I think that it kind of automatically just qualifies it as an ideal L2. The development process needs to be open source. It needs to be decentralized. It needs to be visible so that anybody can come in and not just see what's happening, but also contribute where they want to. Second, I think it needs full virtual machine support and the ability to program with expressive high-level languages. We saw earlier with Bitcoin Script, there's only so much you can do with it. Again, Bitcoin is designed to be money. It's not designed to be a virtual machine. It's not designed to have an expressive smart contract language. It's designed to be as simple, secure, and stable as possible. But that means that we should have that innovation, that expressivity, and that functionality in our L2s. And so I think the second property we need here is this virtual machine support. Ethereum came and proved out the use case for this. Ethereum only exists because this idea was rejected by the Bitcoin community. Personally, I think for good reason, and this is why, because I think this kind of functionality belongs at the L2 level and not at the L1. But I do think it's extremely important to have this functionality to be considered a true and ideal L2. The third is fast transaction and block times. Bitcoin is slow, 10 to 30 minutes to wait for Bitcoin blocks. Since L2s generally work in lockstep with the L1 chain, we have to figure out a way to make it so that we are tightly integrated with Bitcoin, but that we're not having to wait on Bitcoin. And so I'll get into a little bit more of where Stacks is at in this sort of evolution in a little bit, but Bitcoin's slow block propagation time is a result of it being extremely decentralized and simple and secure. So I don't think the solution here is to decrease that decentralization in order to get fast block times. But the reality is that in order for people to actually use it, we just do need that user experience to be better and to be faster. Like Solana's proving that out. People love using Solana. It's enjoyable. It's great. And so how can we kind of have an L2 where we've got the best of both worlds, where we have these fast transaction and block times, but again, like that Fedwire analogy, we're settling back down to Bitcoin after that initial fast user experience happens. Fourth, we need a trust minimized way to move Bitcoin between L1 and L2. So there are currently ways to move Bitcoin between L1 and L2, but most of them are centralized. So we looked at Liquid and RSK. Those live primarily in the Bitcoin ecosystem, but we also have things like WBTC on Ethereum, where we can move Bitcoin from the Bitcoin chain to the Ethereum chain. But that process is almost entirely centralized. WBTC is maintained, I think, exclusively by a single custodian, BitGo. There are other solutions in the works. One of the most interesting ones, I think, is TBTC, which operates on the threshold. But again, if we are looking to stay within the Bitcoin ecosystem, most of these two-way Bitcoin pegs are operating either in a federated way or on a different chain. And for a lot of people, that's not really an option. They want their Bitcoin to stay in the Bitcoin ecosystem. And so that's one of the gaps that Stacks is looking to fill as a layer 2 is how can we provide this trust minimized way to move Bitcoin back and forth, but stay within the Bitcoin ecosystem and stay building on top of the Bitcoin L1 so that ultimately we're still relying on that security. Because as soon as you move to a different chain, well, now you've got all kinds of different trust assumptions and security assumptions. A lot of people don't like proof of stake. A lot of people don't like the direction Ethereum's headed. They don't like how much control Lido has over staking percentage, all this stuff. So there's a market need for a solution like this that doesn't have to leave the Bitcoin ecosystem and ultimately use Bitcoin chain as the parent chain. So that's the fourth property. Fifth, Bitcoin as the primary asset deployed in L2 apps. So when we talked about the Bitcoin L2 trilemma, one of the things we looked at was whether or not it has a new token. And we kind of briefly talked about how one of the things that's necessary in order to incentivize the maintenance of an open network is to have that token so that miners are incentivized to come in and actually produce new blocks and maintain that network. However, we also want people to be able to use Bitcoin in those L2 apps. So what the ideal user experience would look like is I, as a Bitcoin user, I have Bitcoin in my wallet. I don't want to have to take my Bitcoin, send it somewhere else, and then use this other separate token to interact with it and then try to pull my Bitcoin out based on how that happens. What we want to do is we want to make it so that I, as a Bitcoin user, can directly send my Bitcoin to the smart contract on the L2, whether that's a liquidity pool in some DeFi protocol or whatever it might be. I want to let it do its thing, and then I want to pull it back out in Bitcoin. I don't want to have to deal with another token because I'm interested in turning my Bitcoin into more Bitcoin. So the fifth property is that Bitcoin needs to be used as the primary asset deployed in L2 apps. And we'll talk a little bit more about SBTC on the stack side as a solution to that problem. Number 6, ability to pay for L2 transactions in Bitcoin. This is related to the last problem of if I'm primarily a Bitcoin user and I want to use an L2 for scalability purposes or to increase functionality and maybe generate a yield on my Bitcoin, I still don't necessarily want to have to deal with this other token that exists as an incentive mechanism on this other network. Some people might, but a lot of people aren't going to want to do that. And so we should also have the ability to pay for those L2 transactions in Bitcoin. And realistically, what that's going to look like is the protocol handling the conversion between Bitcoin and the synthetic Bitcoin asset on the L2, but the user shouldn't have to deal with that part. That part should happen behind the scenes so that me as a user, I don't have to hold the L2 token in order to utilize it behind the scenes. I can just hold Bitcoin and move my Bitcoin back and forth without having to worry about anything else. Number 7, and this is the big trick with Bitcoin right now, is the ability to unilaterally withdraw your Bitcoin back from the L2 with no counterparty risk whatsoever. So as of now, Lightning is the only sidechain or L2 that gets close to this. And even that doesn't happen 100% of the time. I've heard stories of people losing their funds that they had on the Lightning network, but it's the closest because it utilizes those hash time lock contracts we talk about. What you're doing when you open a Lightning channel is you're depositing your Bitcoin into a time lock contract on the Bitcoin chain. And Lightning still uses cryptography behind the scenes. And basically what happens is if you're transacting with somebody on Lightning and they try to cheat you, that time lock contract you deposited your Bitcoin into, at some point, if that dispute doesn't get resolved on the Lightning side and what they're trying to do doesn't match with the ledger of what's happening on Lightning, that Bitcoin will be sent back to you without you having to rely on anybody else to send it back for you. So Lightning is the only sidechain or L2 that currently has this ability. Our goal is how can we get as close to this as we can? I kind of come from the ethos of if your Bitcoin is not in your wallet with your keys, you automatically have some form of counterparty risk. So I don't think it's actually possible to completely fulfill property number 7, but it's definitely a spectrum where our goal is to make that L2 with as little counterparty risk as possible. Right now, Lightning is definitely the closest to that. And as we'll talk about with how Stacks and SBTC are designed to work, it's also designed to do 2 things. One is to get us as close to that ideal as possible, but also to allow room for innovation when we have future editions of the technology, like let's say rollups happen, where we're actually able to verify and prove transactions on the Bitcoin side, well, that all of a sudden unlocks a lot of possibilities for creating some sort of mechanism here where we can make this almost no counterparty risk. But we'll look at how we're approaching that in a little bit later on. So a little bit of context for what's happening in the Stacks world right now. There is a huge upgrade in progress called the Nakamoto release. And so I'm going to talk about some of that here, but it's all in progress. And so as of now, the current version of Stacks has properties 1 and 2, but is missing the rest. So as of right now, as we're giving this class, it's open source, it has a decentralized development process. It's got full VM support and ability to program with expressive high-level languages, Clarity. We'll get into Clarity too. But right now, Stacks block times are coupled with Bitcoin block times, which is a huge pain point for users and developers because, as I'm sure you know, is a massive pain to try and use and build on something where you have to wait anywhere from 5 to 30 minutes for a transaction to confirm. And it's just not workable. It's just not acceptable in the world that we live in now. So as of right now, Stacks block times are tied to Bitcoin block times. But for properties 3, 4, and 5, the combination of the Nakamoto release, which is the big upgrade that's coming, and SBTC, which is our decentralized two-way Bitcoin peg, those are going to solve this one. They're going to solve number 4, a trust minimized way to move Bitcoin between L1 and L2. That's what SBTC does. And then SBTC will also solve number 5, utilizing Bitcoin as the primary asset deployed in L2 apps. We're going to talk a little bit more about exactly how Nakamoto and SBTC work. But the last 2, 6 and 7. So number 6, this is not going to come as part of the Nakamoto release or as SBTC, but conversations are happening right now on basically whether or not we should allow SBTC to be used as the gas token on the Stacks network, so that rather than a user having to pay for a smart contract transaction in Stacks, they can pay for it in SBTC. The reason that this is not being added to the release as soon as it comes out is because there's some disagreement on whether this basically lowers the incentive for people to mine, because basically if it lowers the value of Stacks so much that it's not worth it. My personal opinion is that I think that we should allow for this. I think we should allow people to pay for their transactions in SBTC, because as we'll see as we get into how Stacks is mined and how its consensus mechanism works, I think the real value of Stacks comes in on the mining and the consensus mechanism side and what's called stacking, which is somewhat similar to staking, and we'll look at how that works too. But that's something that's in conversation right now. The whole ecosystem and community is talking about it, weighing opinions, going back and forth, and so we'll see what happens. We'll see what happens with that. Number 7, again with the design of SBTC, the goal is to be able to allow people to withdraw their Bitcoin back from the L2 into their own wallet with as minimal counterparty risk as possible. The design of Nakamoto plus SBTC gets as close to that as we are able to do right now. And then what's really cool is that with other improvements on Bitcoin that may happen in the future, things like BitVM, the rollups that I was talking about, those will unlock new ways of creating mechanisms to lower that counterparty risk even more. But we'll go into the design of SBTC and Nakamoto and how that's designed to get us that initial lack of counterparty risk as much as we can. So the Nakamoto release brings properties 3, 4, and 5. Biggest upgrade yet, and it's really designed to make Stacks into a true L2. Stacks has been around really for close to 10 years in different forms. The chain as it stands now has been around for a few years, and so sort of been an iterative process of how can we gradually build a technology that is going to be practical and usable, and then just progressively iterate on it and make it more and more decentralized, more and more practical, and more like a Bitcoin L2. And so the Nakamoto release is a huge step in that direction. So talked a little bit about this already, but the ecosystem is still really young, and so work is underway to accomplish 6 and 7. But I want to bring us back a little bit to set the context again and ask this question: what's the main purpose and use case of Bitcoin script? The answer to that is it's to provide conditions under which an output can be spent. And that's really all it does. There's some various scripts and opcodes that we can use in order to make some relatively complex conditions. We can make things like multisigs, we can make these time lock contracts that we talked about, but there's no concept of an execution environment or a fully expressive smart contract language that allows us to do complex things like create DeFi protocols. And so that's why we need L2s. So I want to shift gears a little bit. We talked about how there's two main use cases for L2s, functionality, scalability. We talked a little bit about functionality. Let's talk about scalability a little bit. Right now, we're seeing Bitcoin suffer from a very similar problem to what Ethereum's run into in the past, which is just that high usage leads to high fees on the L1, which makes it unusable for a lot of people. This isn't necessarily a bad thing. It means that the network is healthy and has lots of activity on it. We want high transaction fees. But the problem is that it does make it unusable for a lot of people and unusable for small transactions. So we've seen L2s emerge on Ethereum as a scalability solution to solve this problem, but they've been faced with problems of centralization. I think rollups are really cool, but so far I haven't seen a decentralized version of rollups. I haven't seen a decentralized solution to that yet. That may happen in the future, but I think it's pretty clear that we do need L2s on Bitcoin and on Ethereum. And so right now we're at the beginning stages of seeing how these L2s are actually going to perform when the network really is in this high fee environment and under a lot of pressure. So again, high fees are good for the network, but not necessarily for the average user. So this dual problem of lack of functionality and scalability, that's really what Stacks is looking to solve here. So the goal is for it to kind of wrap all of these ideas up. Stacks is trying to be decentralized L2 for Bitcoin, combining scalability, functionality, good developer experience, which is unfortunately overlooked, but extremely important for people actually coming in and wanting to build on things, which then leads to users actually using things. Then also decentralization, all while keeping the base layer simple and secure. So how does it actually do that? There's 4 main components of Stacks that we're going to go through today. The first is proof of transfer. So this is the consensus mechanism that Stacks actually uses. The second is what we talked about a few minutes ago. It's the Nakamoto release. This is the big upgrade coming to how proof of transfer and the Stacks protocol actually operates. That's going to kind of bring it closer to being a true Bitcoin L2. The third is SBTC. This is the two-way decentralized Bitcoin peg that relies on Nakamoto in order to operate. And then the fourth is Clarity, which is the smart contract language. So quick reminder, and for anybody that's new, this is a ton of information all coming at you at once. I don't expect anybody to retain a lot of this. There's a lot of information happening. I want people to be able to just kind of enjoy learning. And so I'm at this URL, stx.is/Geneva, just have a simple form where you can put in your name, email, GitHub. And after the class is over, later today or tomorrow, I'll just be emailing everybody with a list of like further learning resources, next steps. So that way, after this is done, if you want to dig into anything further, you'll have all the resources you need right there. I'll send you my Twitter, Discord, GitHub. You'll have my email address if you ever want to reach out, all that stuff. So if you want to kind of get further resources and just get connected with me and into the ecosystem in general, go ahead and fill out that quick form. Otherwise, no worries either way. So let's quickly go through proof of transfer, which is the consensus mechanism that Stacks uses. So I'll spend a little bit of time on this diagram, kind of talking through how proof of transfer actually works, because it's extremely central to how Stacks actually operates and what makes it unique when we compare it to other sidechains or L2s. So the way that I like to conceptualize this is, let's start with the way that Bitcoin's proof of work operates. You can think of proof of work as spending one resource, in Bitcoin's case, energy. The more energy you spend, the more likely you are to earn Bitcoin based on spending that energy. So as a Bitcoin miner, you spend energy, you get Bitcoin. And your job as a miner is to weigh the costs and earnings of that in order to make sure that you're profitable. We can think of proof of transfer as just being one level up from this. So with proof of transfer, what Stacks miners are doing is they're spending Bitcoin and they're getting put into a verifiable weighted random function based on how much they spent. And then that puts them in the running for a chance to basically be the new block producer for Stacks, in which case they'll earn the Coinbase reward for Stacks. So it's sort of one level up, from proof of work mining. Proof of work with Bitcoin, we start with energy, spend energy to get Bitcoin. You go one level up to Stacks mining, you spend Bitcoin for a chance to earn Stacks. So that's the basic mechanism for how mining works. But where does that Bitcoin go? So where that Bitcoin goes is that goes to a group of people called stackers. And this is a permissionless open set of people that are locking their Stacks tokens in the network in order to receive as a real Bitcoin yield that Bitcoin that miners are depositing into the network. So right now, as a stacker, you can go in and you can lock your Stacks in the network and you'll earn, it varies, but I think right now it's at about 10%. You'll earn about a 10% APY in Bitcoin. And that's not a synthetic Bitcoin token. That's not like artificial yield. That's the actual Bitcoin that miners are transferring into the network that you're earning as a stacker. So one of the big changes that's coming with Nakamoto and SBTC is that these stackers will now have an additional function of basically serving as they're serving a cooperative role with the miners. So right now, the way that Stacks works is the miners are in charge of, just like in Bitcoin, they're in charge of both the proposition of new blocks and the actual writing and creation and validating and approving of new blocks. One of the big changes with Nakamoto is it splits that responsibility between the miners and the stackers. So right now, the reason that Stacks transactions and Stacks blocks are slow is because Stacks blocks are mined in lockstep with Bitcoin blocks. So whenever a new Bitcoin block is mined, a new Stacks block is mined. What Nakamoto does is instead of miners mining Stacks blocks in lockstep with Bitcoin, what happens every Bitcoin block is that a new miner is selected for a tenure of a whole Bitcoin block. And what they'll do within that tenure is they will write several Stacks blocks within that tenure. So the estimates right now are that new Stacks blocks will be created once every 5 seconds. So the stacker's role in that is to make sure that those miners are building atop the correct chain. So right now, Stacks can fork separately from Bitcoin, so it has its own security budget, which is one of the reasons why I think until Nakamoto's released, it's not really a true L2. But because of this update where the responsibility is split between miners and stackers, it's actually not possible for Stacks to fork separately from Bitcoin anymore. As part of a miner starting their tenure during a Bitcoin block, they have to provide a hash of the previously mined block and everything that came before it. And it's the stacker's responsibility to verify that they are building atop the correct chain tip. If they're not, then those transactions get rejected. And the miner doesn't get their Coinbase reward. And so what this does is it allows us to tie the Stacks chain tip directly to the Bitcoin chain tip, and it allows Stacks to fork with Bitcoin. So why is this important? Because now we have 100% Bitcoin finality. Part of mining a new Stacks block is you also mine the hash of the Bitcoin block that it's attached to. And so since this is part of what's considered valid block production rules, every Stacks block right now, and the way it works now, has an associated Bitcoin block. And that's why it's tied 1-to-1 with Bitcoin. In the new system, whenever a miner is elected to start mining new Stacks blocks, which happens at the start of every Bitcoin block, they will be required to prove that they are mining on top of the correct chain tip. And then they can add all of their Stacks blocks, again, very quickly, about every 5 seconds. Stackers now fulfill a dual role of validating those blocks. So a miner will propose a new block, the stackers will validate it, and then it will get added to that miner's collection of blocks. Once it's time to switch to a new miner, which happens at the end of the Bitcoin block, in order to process that tenure change where the miner is switching to the new miner, they then have to provide a hash of all of those blocks and transfer it over to the next miner. And again, the stackers are responsible for making sure that actually happens. So the stackers kind of act as a little bit of a policing to the miners to make sure that they are mining honestly and they receive those Bitcoin rewards from the proof of transfer that we talked about. So rather than all of the responsibility for producing and validating new blocks being on the miners, it's now split between the miners and the stackers. So this is all part of the Nakamoto release. So we talked about before how Stacks is missing number 3. Fast transaction block times don't need to wait 10 to 30 minutes for Bitcoin blocks. Trust minimized way to move Bitcoin between L1 and L2. Bitcoin is the primary asset deployed in L2 apps, and the Nakamoto release fixes this. Talked about how it has those fast blocks. We've got that 5-second block production time within the Bitcoin blocks. And then we also talked about how it's got this 100% Bitcoin finality now. And this is, I want to drill this point in a little bit because this is really one of the key things that makes it a true L2, because it has to track with Bitcoin in order to be a true L2. If it can fork separately from Bitcoin, it's got its own security budget and it's not relying on the hash power and the security of Bitcoin. And so at that point, we just have a totally separate, that's where I think it would be more appropriate to call it a side chain, where we've got a whole separate economic security budget here. We're just moving things back and forth. But if it's inheriting Bitcoin security, which with the new Nakamoto release it is, once a miner has changed tenure, all of the blocks that they processed are as irreversible as a Bitcoin transaction would be, because of the way that the hashing mechanism works and the way that Stacks is recording the hashes of the previous blocks to its own blocks, but also to the Bitcoin blocks. We have that 100% Bitcoin finality. If all of this is confusing or fuzzy or you're not tracking, that is okay. All of this is in development right now. As design decisions for the system start to get finalized, they'll be released in what's called a SIP. SIP is a Stacks improvement proposal, and this is how changes to the chain are made and processed by the community. So what will happen is the core team will finalize all the design decisions. They'll put that forward as a SIP proposal, and then Stacks holders as a community will vote on that SIP proposal. If it gets voted yes, those code changes will be pushed and merged into the chain, and this will actually happen. But the nice thing about the SIPs is that you can go through and you can read in detail exactly how all of this is working. So once those are released, those will be a really great place to go and see exactly how this stuff is working. Because I know right now, just talking through it, looking at slides, even for me, it's all still a little bit fuzzy. And then one of my other roles at the foundation is I work on the docs. So as these SIPs start to come out, I'll be integrating all this content into the documentation to try to make it a little bit more accessible for people. But let's go through a couple quick things about sort of just into a little bit more detail about how this works, and then we'll take another break here in just a few minutes. But one of the important pieces of this is we have to decouple the Stacks tenure changes from the Bitcoin block arrivals. So we talked about this a little bit, but the way that mining works right now is miners take turns appending blocks to the Stacks blockchain, and the miners are selected by cryptographic sortition. That's just the cryptographic process of selecting what miner is going to propose and produce the next block. But then the difference is now, instead of just producing that one single block in lockstep with the Bitcoin block, that cryptographic process is going to select the next miner for their tenure, and they will rapidly produce multiple Stacks blocks within that tenure. And then at a protocol level, the next miner is required to confirm all of them. And so that's kind of how we keep that. That's how we keep that chain going. And that's how we produce those fast Stacks blocks. And then we also have to have stackers collaborate before the next block can be produced. So we have this sort of symbiotic relationship between miners and stackers where neither of them will get their rewards, the Coinbase rewards in Stacks in the miners case, and the Bitcoin yield from the proof of transfer in the stackers case. They don't get those rewards unless they fulfill these roles. And so they're economically incentivized to do so. And we have this collaborative relationship where even if we have a small group of miners that want to act maliciously, they can't because they're being checked by the group of stackers. And it's significantly more accessible to become a stacker. They're both open networks, but you just need a lot less resources to become a stacker. And so the group of stackers is large. And even if that makes it so that even if the group of miners is small, we still fall back on the level of decentralization of the stackers because the miners can't go on and produce whatever forks that they want or orphan any confirmed transactions because the stackers are not going to approve that block to be produced. And so it really aids in decentralization because as we see in Bitcoin mining, and the same thing can happen with Stacks mining. It becomes an economy of scale where it's just not feasible for everyday people to be mining Bitcoin blocks. Same thing with Stacks blocks, unless they're in a pool. We have mining pools. Stacks is in the process of making a decentralized mining pool, but it's much easier to be a stacker. And so that allows us to kind of fall back on that level of decentralization, and they have checks and balances on each other. About that. So the reason that this all is able to be done is because we're requiring Stacks miners to commit the indexed block hash of the first block produced by the last Stacks miner and their block commit transactions on Bitcoin. So the way that Stacks blocks are mined is by miners making a block commit transaction on the Bitcoin side, where they are recording the hash of all of the transactions that have happened in the Stacks block that they mined. And that's the way it works right now, is all that they're doing in that block commit transaction is they're adding the hash of the Stacks block that they mined. But now this adds an additional requirement to where they also have to add the hash, the consensus hash of all previously accepted Bitcoin transactions that Stacks recognizes. So basically they're hashing the current block and they're hashing the history of every transaction that's happened up until then. And then the stackers will compare that with what the new miner is trying to mine on top of to make sure they're mining on top of the correct chain, which prevents forks, which prevents rogue miners from going off and doing whatever they want, trying to start a new fork of the Stacks chain or trying to double spend previously confirmed transactions or anything like that. So these design decisions are really what transforms Stacks into what I think is a true Bitcoin L2, and they also enable SBTC. So we'll go ahead and we'll take the next 15-minute break now, and then when we come back, we'll get into what SBTC looks like. If anybody has any questions right now, go ahead. Otherwise, I'll see you guys in 15 minutes.
I have a quick question. How can I become a stacker?
Yeah, so let me pull up a link here real quick. So there's there are multiple ways. There's a minimum threshold for stacking, and so what most people do is they'll stack via a pool. There are both custodial and non-custodial pools. They vary between being centralized and decentralized. Personally, the one that I use is run by one of the wallets in the Bitcoin Stacks ecosystem called Xverse. But I'll post in the chat here. This is the page on the Stacks website that kind of goes over more about not only what stacking is, but also where you can stack your stacks. And so the way that I do it is through a company called Xverse. They run a wallet. But what actually happens is basically what I'm doing is I have the stacks in my wallet, and then I can delegate Xverse to stack it on my behalf. And the cool thing about that is I'm not actually giving up the custody of my stacks. I'm just calling a smart contract that Xverse runs and is publicly accessible just like any other smart contract. I'm calling a smart contract function to delegate my stacks to them to stack it on my behalf for a period of 2 weeks. And then I can choose whether I want to basically auto renew that to where it'll restack every 2 weeks, or if I want to do it more of a manual process to where then I can pull it out at the end if I want to. So there's multiple ways to do it. Some exchanges do it. It's a custodial solution, obviously. A lot of people go with that just because it's easiest. I prefer to do the non-custodial solution where I'm delegating it to a smart contract on my behalf. So multiple ways to do it. You can also stack directly, but you do need a minimum. The minimum amount changes. I'm not sure what it is right now, but it's relatively high. And so that's where the pools come in.
Yeah. And how large is the current history?
The history of the Stacks chain itself?
Yeah. Is it super large or is it like reasonably large?
Let's see what block we're at right now. So the latest Stacks block was 131,278. And right now, Stacks blocks are in lockstep with Bitcoin blocks. So you can extrapolate that out to, an average of 10 minutes and figure out how long it's been around. But the chain is in its current form has been around, I think, since 2019 is when the current version of Stacks went live.
Yeah. And how many developers work on the Stacks project?
On the core team right now, working on like the chain itself and SBTC and everything. I think it rotates since it's a decentralized system. We've got people, that come in and out, but I think it's usually around 40 to 50 that are working on the core system itself. And then we've got other developers that work in like companies in the ecosystem. There's a few people that are building out some DeFi protocols as like early testers for SBTC and Nakamoto. They have their own developers, but as far as the like core contributors, we're usually hovering between 40 and 50 at any given time.
Okay. Thank you.
Yeah. Cool. Anybody else? Go for it. Otherwise, yeah, we'll be back in 15 minutes. So be back right about halfway through the hour.